Hi everyone, I am Bhargav. Welcome to new machine learning project. It is about the drowsiness detection in drivers using Python and machine learning. Firstly, let's see the demo. Then after we write the code. Uh, for that, you open the spider. Here is the code. Now run it. See it appears. Now when you click on the open camera, the camera will open and start detecting the drowsy or non-drowsy. See it opens and it's showing that non-drowsy means if you open your eyes it shows that non-drowsy. Next after that, see when I click on the into button it not open, it reloads the camera blue and so that we have to stop the camera. And then after this what happened means after that it opens the, see, you can see this, start machine learning algorithms. Let me show you. See here, see the output will generate. We train it on CNN model. See the CNN model, and then after the random forest accuracy will appear based upon the image capture images that are in drowsy images and non-drowsy images, which is classified based upon the facial recognitions. So this is a project about to find the accuracy with random forest and some other algorithms to, and other algorithms like KNN to check which gives the better accuracy when compared to the others. And also we are saving the photos on live camera sensing using facial recognition and other things. So let's start the code newly. For that you have to create one folder. Let me show you. Just create a folder on your desktop. Okay, in that folder again create two more folders. One is for drowsy images and another is for non-drowsy images. Okay, now what we have to do is open your spider program environment. So it opens. Now we have to write some code here. Just write anything and save it on our project. Name it whatever it is. Okay, now for this project we have to import some libraries. Initially we create the camera and start detecting, then after that we do some algorithms on that. So for this we need import cv2 and import time. For every 10 seconds it has to save the images whether it is drowsy or non-drowsy. And also we use the Tikinter as TK, and we also import some wind sound for beep sounds. If we found the drowsiness, then we use the wind sound, then import OS and some numpy values. You know all that numpy, numerical Python as a NP, instead of using the arrays, it is very accurately performs. Then here onwards, just define a global variable, that is I'm calling it as cap variable. It is globally, so globally, initially we take cap is equal to none. Now what we have to do that, firstly in it, let's write the function, main function, because we call the other algorithms as well, so that we are creating the main function here. If name equal to uh, main, then what we have to do that, firstly we have to uh, initialize the tikinter for an applied or whatever it is, we call it as a frame or anything, so that I take root is a variable. In that root we call the tikinter. In that tikinter, we are creating a title. The title is about drowsiness detection. Okay, now we have to create a frame. Okay, for that I called frame as a variable, frame tk dot frame of root. Okay, the root is the main part here. On that frame we call the packages, that means padding of x 60, and padding of y, it means it takes the measurements of the frame. Then after that we are creating a label to display the camera feed, right? For camera feed we are creating a label, that means label equal to tk dot label of frame. um, Next, for this label we don't have any other tags, so simply ignore that, but we have to mention it. Next one, we have to create the buttons for open camera button and another close camera button, right? So open camera button, we are calling the button in Tkinter, which is default here. In that, for that button we have to create some frame and text it with open camera, and also we have to command that uh, when you click on the button you have to start camera. Here the start camera is not a default, we have to call the function. It is user defined function, I will explain after that. Next, for this camera open camera button we have to import some packs, that means it should be on in this side. Okay, one side, that is the left side, and next we have to pad it as pad x, equal to, here we use the 60, right? Then take 10 below itself. Then after that we have to create the stop camera button or stop button, okay, whatever it is. tk dot, again we are calling the button. In that button, same thing, but some changes will appear, so just copy it, paste it here for the text, close it, and here instead of stop we call the stop camera instead of start. Okay, now for stop camera also you are using the same tags, because it should be equal, the buttons should be equal. So that here what we have to say that stop button dot tag. Next, uh, for this we are giving the 20, because it is the padding of x value, so that we are using that. Then after that the main group will again continue. Okay, next what we have to do that, we have to target the shape. It means while you are uh, open the camera, there are different type of shape and sizes will appear. It may only takes the eyes, or it may takes the entire face based upon the facial features. You take that, so that the images may or may not be the equal, so that we are targeting the shape. It means, let me write here so that you can understand. Desired shape, okay, the shape must be same. Then after that drowsy images, and we are training the data, so that we are, let's take different drowsy images and drowsy labels. Why we are taking that means, uh, for saving the images and reloading it. Okay, for that we have to mention the path, drowsy path, and it should be 0, and target shape. Here what happens means, um, reload images is a user defined function. We will write after that this code completed. In this reload images, what happened means, the images are going to save in the four different folders, that is drowsy path or non-drowsy path. Okay, based upon this the accuracy, we find the accuracy, so that we are using this. And even we also use this, right? Non-drowsy images, sorry, let's take here. Okay, non-drowsy images and non-drowsy labels. The labels means it appears when you found drowsy or non-drowsy, and the images means the identified images will be reloaded. Okay, sorry, non-drowsy images, and also we have to take okay, reload the images, and in that non-drowsy path, right? So non-drowsy path will taken, and target shape. The target shape is 100 and 100. Height and length and width will be 100. So now from this onwards, it is all about that we are opening the camera button, and after taking some found that the images are drowsy or non-drowsy, so that what we are using that main loop. So it founds that it whether it is a drowsy or non-drowsy. Then after that, if it is whether it is drowsy or non-drowsy, it would be saved, so that I use the reload images, so that the images will be equal. All the images should be equal. We must take that the images should be equal, because the accuracy may changes, because if the shape size is not available, then the machine learning can't understand whether what images we have to take, so some errors will found, so that we are equalizing the images. Next one is that we are applying the machine learning algorithms here, ML algorithms. For that, we are calling the CNN model itself. CNN model is a actually it is a deep learning model. Why we are using that means for uh, recognizing the drowsy and non-drowsy images. Okay, non-rosy images, and also we have to take the labels as well. So drowsy labels and non-drowsy labels. Only for CNN we need that. For KNN only call the KNN model. Okay, it is also a user defined functions. We have to write those things. Okay. Next, it is all about the main function. Here we use different type of user defined functions, like reload images and CNN model, KNN model, random forest. These are all things, right? And the main loop, where is it? Here the main loop. We have to create all these things above. For that, mm, initially. While you are performing the machine learning algorithms or anything, you have to pre-train the images or whatever it is, the we have to train the data, but we are using the images here, so that what we are doing that, uh, that's right here, we are loading pre-trained face and eye, because it is particularly on based upon face and eye, so that uh, face and eye we are cascading the classification by using classifiers. Okay, for this we need to install some classifiers firstly, so that uh, we are using some more uh, libraries, like image image tk, and also for this machine learning we are using sklearn and tensorflow, so that from sklearn we are assemble ensemble ensemble we are importing random forest for classification. Make sure uh, Next, from escalon, we are again calling the neighbors import k neighbors classifier, and from escalon dot model selection, uh, import in that model selection we are importing train and test the splits. Okay, next, from escalon dot metrics, I will explain all these important libraries for machine learning. These are inbuilt libraries which find the different type like classifiers, uh, and training the data, neighbors, accuracy score. Okay, next, accuracy score is over. Now we are importing TensorFlow applications. TensorFlow dot keras dot models, import sequential. Okay, and from TensorFlow dot keras dot layers, we are using the layers. Those layers are convolutional, two-dimensional, max pooling. Okay, pooling 2D, layers, max pooling 2D, and flatten and dense. Why we are using, I will explain to that. Next one is that we have to load and pre-trained phases, right? So that what we are using, that phase cascade and eye cascade. Okay, these are the variables we are taking. For phase cascade, we are using CV2 cascade classifier. In that cascade classifier, we are again using the data, uh, data dot har cascades. It is the default thing. We are not we are using it, not any user defined. It is a predefined. We are creating an XML phase. Why we are using the XML phase means, um, okay, to detecting the uh, easy thing. It means when you close the eyes, the values may changes on your facial features, and also when you open your eyes, the values again changes. So for detection, we are using these things. These are all comes under default things. Okay, now what happens here in this code? For the main loop, we are pretend it, right? Now what we are doing that drowsy path and non-drowsy path, these are the important. For that drowsy part and non-drowsy part, what we have to do is we have to define the path for non-drowsy and drowsy. Okay, first we take this drowsy path, and again then after that non-drowsy path. Here you are calling the uh, for this what we have to do that here is a drowsy images, right? Just simply go through here and cut it and paste it. Here this symbol represents that we are extracting the images or we are extracting the data, so that this symbol is happening. So we are importing the packages, so that we have to change the symbols like this up to the drowsy images. On the drowsy images folders, the values will be the images will have to save, so that we are using that. And similarly for non-drowsy images, just go through here, cut it, and then what we have to do that here paste it. Similarly, change the values. See, the value is non-drowsy, right? The spelling mistakes may happen here. So just remove this and B. Okay, now we successfully import the path. We define the path. Next, what we have to do is here the main loop is there, no? And also the camera will again reloop it. So start and stop the camera. Okay, these are the variables here. So we are using the start and open camera predefined functions. Sorry, user defined functions. So for that, um, let's define it. Where we have to simply here start camera def start camera. Initially we use the global cap, right? So we are accessing here, and next that cap equal to cv2 dot video capture. Okay, in that video capture we are using only the 0. We don't need any these things. Okay, if we have to write the condition, if the cap is opened Then what we have to do? Just print is not opened, right? So error, failed to open the camera and return it. Then run the camera loop again. Okay, I will explain why I wrote that. Okay, it is also user defined. Now stop camera. For that def stop camera. In that stop camera, we are again using the global cap to access it. If cap is not none, initially we use the none, right? So when you open the camera, it not appears like a none. So we are using that. Now destroy all windows. Okay, when you stop the camera, it stops the camera and destroy the window. It means camera window will be destroyed. That means close. Okay, here I mentioned. Now what we have to do is uh, now we have to save it. Function to capture the images. Capture and save the images. Okay, for this we are using def capture and save images. In that we are using some frame and drowsy. Also another function is that please note down this. Your reload images also we need. So def reload images. In that we need folder path and labels and a target shape. Okay, next we need another functions. Start camera and stop camera, capture and save and reload the images, and again and then after that we need def detect drowsiness. Sorry, before that we need to add uh, run camera loop. It is very important. Run camera loop, start camera, stop camera, capture and save images, reload images. And next what we have to do is that here I mentioned next function for load and pre-processing. Okay, pre-processing the data, right? We have to load it and pre-process it. So that what I am using that def what we call load and pre-processing the pre-processing. That's it now. Pre-processing images. Okay. Just whatever it is name, please keep it on mind while you are using that function. Okay, folder path, we need folder path, and for that processing image we also need labels, and what we need is some common shape. Okay, not target shape, common shape, or else whatever it is the target shape as well. And okay, let's do one by one. We need these functions. Firstly, what do we do? Just you write the run camera loop. Okay, global cap, we are using the to access it. If cap is none or not, cap dot is opened. Okay, what we have to do that, printing some error, camera is not opened. Okay, and we have to return it. Then what is that, sorry, okay, red or frame. Red means uh, appearing the frame. Okay, if red, whatever it is, your name, take that name and note down while using another things. Okay, if red, then actually I taking the gray, so that I using the gray as a variable. Next, in that frame, comma cv2 dot color color vgr to gray. Okay, I taking the gray. Whatever you takes, be careful, because the face values may change. Okay, here what is using that for faces, we are using the we have to detect the multiple scale. On that we are using the gray, comma 1.3, we are taking the 1.3 and 5. Now what happens, for every x we are taking some values w and h in that faces. Okay, different dimensions are there. No, it face is a different dimension, so that I using the rectangle shape for frame. Okay, it means we are creating the frame on face itself. Okay, we are detecting the multiple, we are using the multiple scale for detection the face. On that face, when the person is drowsy or non-drowsy, we are appearing some rectangle scale. It shows whether it is drowsy or non-drowsy, so that we are using the rectangle scale, and we are taking some measurements here, x plus w and uh, h, or okay, y plus h itself. Okay, and some colors we need, right? Using 255. If you know the values, just write it, or else use any other website to take the values. And here I using some watercolor, some color on that frame. We are mentioning the dimensions here. Okay. For now, for eyes, for eyes, eye cascade, eye cascade dot detecting the eye value. So detecting multiple scale. In that multiple scale, we are using Roy Gray. Where is Roy Gray? Means um, Roy Gray. I have to mention the values, right? Uh, y is to y plus h, comma x is to x plus w. Here also for Roy color, we are using the same dimensions, but gray array is different and frame array is different. We are using numpy for that only. Okay, next what we have to do, that we have to detect the drowsy. Drowsy equal to uh, detect, what we called here, detect drowsiness. Now capture and save images, we need that also. In that we are using raw color and drowsy. And now what we are doing, if the person found drowsy, then cv2 dot put some text on that frame. Okay, that is a frame, not image. And we are using the x comma y, no, text is right. So it appears drowsy, and organize it. So y minus 10, it is the scale where we have to put the text on that frame. And next font face and font scale, for this we are using the default cv2 dot font simplex. We are using the simple one. Then 0.9 is the value here, and 0,255 for two eyes, right? Next, if drowsy, or else what? So else the same thing, just we are changing the value. Now drowsy, Let's make the difference. Okay, one is blue and another one is red, so that we are using this. Now what how to do? Next, cv2 dot in show, it will appear like that on that drowsiness detection frame. Okay, if cv2 dot wait key, it means delay for saving. I use 27 here. Exit, it means what it means. I will explain that. What it means exit if the key is pressed. Okay, what happens? We call the stop camera function when you click on the key. Okay, now call the function again after a delay. Okay, it means when you escape it, then the function will appear for 10 seconds, then again camera loop will appear. Now what? And then here I mentioned that detect drowsiness, right? Well, let's create it. For that, again, let's create def. No, detection function. Okay. For that def, what I mentioned here, detect drowsiness, right? Simply paste it here. In the detect drowsiness, we are using the frame and eyes only. In the eyes, here is the main loop. If length of an eyes equal to 0, then return true. It means, let me mention here, it means drowsy. Else return false. It means non drowsy. Okay, simple, right? Then after that, there are some functions here. We have to note down it. Before that, we have to capture the image. Okay, capture and save the image. For this, where we have to save that images, we are using the folder path. Okay, so for folder path, we are using the drowsy path. Okay, in the drowsy path, if drowsy, else non drowsy. Uh, then after that, we have to name the file to save it. Here folder path, mm, image, integer, time dot time. JPG. Here why I use this time dot time means it note down the time while the drowsiness or non-drowsiness is detected when you open the camera, and the folder path it must have to name it as a folder path and slash of image so that user can understand, and or else any other project doing persons also can understand. So I mentioned like that only. Okay, cv2 dot next what we have to do is we have to write it right. This is a default, not ourselves, user define print image capture and file name. Now what we are doing that image is captured. If it is drowsy, then win sound right. We have to use that win sound dot beep up to 500 2000. The sound will appear like beep. Okay, alert sound. Next, capturing and saving images is over. Stop images is over. Start reload. So next one is that reload. For reload images, we are taking some array values that is called images and labels to reload. And why reloading it? Because we need to find the algorithms, right? So that we again use those things. For file name or okay, file name in our OS. So in our OS dot path dot join the folder path, okay, and the folder path, then file name. We use all the files, okay. Um, no, the thing is OS dot uh, directory, right? Folder path. In that we are using an image, it is img equal to cv2 dot read read. Now we are using os dot path os.path.join folder file name. In that file name also cv2 dot we are using default. I am read only in grayscale, any color not. Okay, I use the only grayscale, right? Next what we have to do is, if image is not none, it means the image have some values, then image should be resized itself. So that for resizing itself we are using cv2 dot resize img image and some common shape. Next images dot append it. Okay, image resized, then labels we need append it on labels itself. Now return it. Return the both the images and labels. Okay, so from now on this on again we have the load and pre-processing the images. Hmm, so we don't want any this, we only wrote there only, so just ignore that. From this it happens. Now you have to write the algorithms. These are all the just functions for front end and opening the camera, stop camera, some other detection and drowsiness, all these things. Let me show you. Just ignore these things. Okay, let's see it runs or not. Okay, it is running. Now let's run it. Oh, sorry, I didn't follow. See, there are some errors like we forgot the comma here. Where is it? No, here. Yes, I forgot the comma. Let's run again. Okay, no module named scalon matrix. So we didn't call any machine learning algorithms, right? To find as accuracy. So simply ignore that and run it. It happens. Okay, also some errors will coming. It means okay, okay. Instead of using hyphen, we use the underscore. Okay, now run it. Okay, some max pooling. Oh, sorry, it's a spelling mistake. It's max pooling 2D. Now what? I think it is running. Yes, it is running. Okay, it is running. Oh, okay, camera is opening And some errors is there. CV2 has no attribute CVT color. It means I'm where is it? Yes, CV2 color on gray. Yeah, CVT color. Okay, it should be the capital. Okay, so again restart the kernel. Okay, let's run it. Let's see. Yes, it is opening. When you click on the open camera button, uh, it start detecting. But the spelling mistakes like frame, I use the frame. Okay, these are the simple spelling mistakes, but the logic is right. Okay. Okay. Again, restart the kernel. Okay, now run it. Okay, it updates. Yes, it is appearing. Okay. Okay. Now we have to perform the machine learning algorithms. For that, please do subscribe, or I will explain it on next video. Okay. Thank you.